Hi, welcome to Chapter 8D, Amortizing Loans. In this chapter, we're going to distinguish carefully between loans and bonds that are not amortizing and those that are amortizing. Amortizing just means that a portion of each payment is going to include some interest and a pay down on the principal originally borrowed. Examples of amortizing loans are mortgages, many car loans, things like that. So once we've got that figured out for sure, we're going to take a deeper dive into amortizing loans and understand the mechanics of how in each payment, a portion of that payment is going to be interest, another portion is going to be paying down the principal, and how we can figure out how much of each is hiding inside each uniform payment. So as always, let's jump right in.
Okay, so let's get started. So far, we've been working in general implicitly with two different types of loans. The first is non-amortizing loans, and these are characterized as follows. No portion of the loan principal, meaning the original amount of the loan or that face value of the loan, is going to be repaid until the end of the contract. And that means, of course, that the loan principal is fully repaid at the end of the contract. And also, this implies that all payments from the borrower to the lender before the end of the contract are going to be interest-only payments. So we've sort of separated out the interest payments from the repayment of the loan principal or the face value. The second type of loan that we've been looking at are called amortizing loans, although we haven't called them that. And in these cases, every cash flow from the borrower back to the lender contains some amount of principal repayment, and that's called amortization, and some portion of interest payment. So with these loans, the two pieces are intermingled in each payment. The type of loan that any given loan is always determined by its contractual terms, not the arrangement of its cash flows. That said, in this class, we're going to say, and this is true most of the time, we're going to say that all uniform cash flow projects are amortizing. So that'll include things like mortgages and leases and financial annuities, and all other projects are non-amortizing. So that would be things like semi-annual corporate and treasury bonds, other types of loans that work that way, etc. And the good news, happily, once again, is that all the formulas we've used so far are going to work for both amortizing loans and non-amortizing loans, and bonds too, whenever these things are applicable to bonds. So here's an example of a non-amortizing loan. So I've got for this loan a cash flow diagram here. So this would be for the borrower, right? Because the borrower gets the blob of, say, 100 million at t equals 0. And then you see each of these uniform payments of 10 million are the interest. And let's write that in. And then down here, in the last payment, we have an interest payment and repayment of the principal. And this is the principal that is initially borrowed. So in words, we can say that the borrower gets that 100 million now in return for making these 3 periodic interest payments and repaying the principal at the end of the term of the contract, which is called the maturity date of the loan. And as we've seen up here, always with these types of loans, the last payment always includes a final interest payment and the repayment of the principal. So here's an example of an amortizing loan here. And this is going to be for the lender, where they've got their PV tote or CF0 down here, which is money they give to the borrower in return for a set of uniform payments in the future. In this case, each uniform payment is $3,500. So again, summing this up formally in words, we say the borrower gets that PV tote now, and they're going to be doing that in return for making 5 uniform payments back of $3,500. And the key point here is that each of those payments now is going to include an interest portion as well as a principal repayment portion. So that's going to be really important for this type of contract. So we have interest and principal hiding in there, interest and principal hiding in there, et cetera, the same for all 5 of these repayments. So what we'd like to do now is to determine how to extract the interest portion of this payment and the principal repayment portion, or the amortization portion of this repayment, and then be able to do it for this one and this one and this one and this one, to be able to do it for all of them. So that's what's coming up on the next slide. So let's illustrate how this works with an example. So let's go back to the Mr. Small Net Worth mortgage example for his shack. And remember, we had a lender giving Mr. Small Net Worth $30,000 now to help him buy a $50,000 shack. So that means he puts in $20K of his own equity, right? $20K of his own cash. Total price is $50,000. The mortgage is going to pay $30,000 of that, so he's going to have to cough up $20,000 from his own bank account. And he's doing this in return for 3 equal annual payments of $12,063,000 per year. And the lender is charging an annual compound interest rate, R, of 10% in this case. So here's what the cash flow diagram looks like for, in this case, the lender. So they have the negative amount, CF0, going out in return for these future payments, all equal, 3 of them, at $12,063K. And what we'd like to find now, for each cash flow, we'd like to find the principal repayment amount. That's called the amortization amount, and the interest payment amount. And we're going to have to work a little bit like detectives here, because these amounts are hiding in the uniform cash flow amount of 12.063. So we want to extract out the pieces of this total payment. All right, on this page, it's in gray, so you can ignore it. It's just a reminder of how this $12,063 payment was determined. We'll move on. Okay, so to solve this, the first thing that we'd like to do is note that for each uniform payment, there will be an interest portion and an amortization portion. And specifically, the way we can compute the interest portion is that's always going to be the beginning of period loan balance times the interest rate. So that will be our 10% in this case. And the other piece, which will be in each payment, is going to be an amortization portion. And that's going to be always equal to the total payment minus the interest portion. And we could call the amortization portion also the principal repayment portion. And the next thing we want to note is that we're always going to use an amortization table to figure this all out. This is pretty much the only way to solve these problems, and this is done by everyone who is involved with these types of contracts, for mortgages, for leases, etc. The lender will do it, the borrower will do it, etc., etc. So how do these tables work? First thing is, good thing to remember what your interest rate for the project is. So I always put this way up at the top. And then the way the rest of the table works is the first column lists the important items for the loan. And those are going to be the beginning of period principal balance, the loan payment made in that period. And we're going to assume that all of these are made right now at the end of the period. So we're not doing this for annuities due. We're not doing this for leases, but we're doing this for mortgages or financial annuities or something like that. And we want, for each of our payments here, we want to know what is the interest portion and the principal repayment portion. And then we're going to want to know, because principal is being repaid each time, we want to know what our ending principal balance is. So let's see if we can fill in this table completely for Mr. Small Net Worth. So I've got end of year 0 here, and that's, of course, as always, t equal 0. That's our beginning time. And then I've got end of year 1, end of year 2, end of year 3. And that's when the payments are made with a mortgage or a financial annuity at the end of the period. So let's start with t equals 0, or end of year 1. There's no beginning principal balance, no loan payment is made. It's the very start of the contract. Think of it as exactly when the contract is being signed. So as soon as the contract is signed, the clock starts running, and the end of period, the t equals 0, beginning balance is 30. So now let's go on to end of year 1. What do we have here for the beginning of period balance? The beginning of year 1, the balance is always the same as the end of the prior period. So this is always going to be true. This is always going to work across periods. That end of period balance in year I is equal to the beginning of period balance in year I plus 1. So that's gonna certainly help us out a bit. And let's go down, and I'm just going to go line by line here and try and fill in everything for year 1. And then you'll see we'll be able to do the same thing very easily for years 2 and 3. So what's our loan payment? Our loan payment is given in this case. Given, and we know what that is. It's equal to our 12.063. Okay, and the interest payment portion of that is equal to what? We know that from what we said up here. This is always going to be true. That's our BOP balance times the interest rate. So let's put here *1 next to that. And to remind ourselves what's going on, let's put *1 down here. And let's compute this over here in our calculator. So interest pay for EOI 1. So we're going to have BOP val times our interest rate, and that's equal to 30 times 10%. And I can even do that in my head. That's equal to 3. All right, so our interest payment in this case is equal to 3. So let's put that in. Okay, and now our principal payment, again, we learned what that is up here. The principal repayment, or the amortization portion, is equal to the total payment minus the interest portion. So let's put a *2 up here to note that, and put that down there just to remind ourselves how we got it. And let's go ahead now and get the principal repay for EOI 1, which is really year 1, because all the payments are made at the end of the year. So this is equal to our total payment minus our interest portion. Okay, so that's going to be equal to 12.063 minus 3. And in most circles, I think that's equal to 9.063. Maybe not my circle if I haven't had enough coffee, but I think I have right now. So I'm pretty confident that that is right. So we've got our 9.063 there. And now we can get our ending principal balance. The ending principal balance is always going to be equal to the beginning principal balance minus the amount that we've repaid. So let's compute that down here. So this is going to be happening at end of year 1 after, of course, the payment has been made for year 1. So that's going to be equal to the BOP balance minus repayment amount. So that's going to be equal to, our beginning balance was 30 minus 9.063, and I think in most circles that's 20.937. Okay, so let's put that in here. All right, so far so good. So now we can do exactly the same thing for years 2 and 3, and we're going to be good to go. So first thing we want to note here is that the ending balance for year 1 is exactly the same as the beginning balance for year 2. Same sort of idea as we had starting at the beginning of the project. And now I think we can say here with extraordinary confidence that the uniform payment, since it's a uniform payment, is 12.063. And since that's a uniform payment, we can go ahead and put it in year 3 now at this point too. That's the whole point of a uniform payment, right? It's uniform. It's going to be the same in all periods. All right, so that's looking pretty good. And so now what's our interest payment going to be for year 2? Let's put that in here. All right, so again, it's the beginning of period balance times the interest rate. So in this case, it's, what's the beginning of period balance for year 2? It's 20.937. And we want that to be times 10%, and that is 2.0937. Okay, and then our principal repayment now is going to be for year 2 is again the total payment minus the interest portion. So in this case, it's our constant payment minus 2.0937, and that's equal to 9.969. So we're going to have a little bit of rounding error here and there in this. And now our ending balance is going to be computed down here. So we want this for year 2. And so this is going to be the BOP balance minus the principal amount. The BOP balance is over here, 20.973. Our repayment amount in this case is 9.969. And I think if you work that out, you're going to get something like 10.967. And we'll say plus or minus for a little bit of rounding error. Now we could proceed doing the exact same thing with year 3. First thing we want to do, as usual, is note that the end of period balance on the loan in year 2 is equal to the beginning of period balance for year 3. Next thing we want to notice is that our uniform payments remain uniform payment, same for every 3 years, and then we just do exactly what we did for year 2 and year 1 to calculate the interest payment, the principal repayment, and the end of principal balance. One thing that's really important to note here is that at the end of these guys, these amortizing loans, the principal balance after the last payment better be 0, right? Better be 0 plus or minus rounding, because after the last payment, there's nothing left to pay. There's no more principal left to pay. So that's always a good check. So I'm going to leave it to you to compute these two numbers and make sure you get to something close to 0. And if you need some help with that, I've got the complete table for you here. So you can check your answers with the numbers I have for year 3. All right, so what are some of the key points of this? First thing is, let's remember that each uniform payment, the whole idea here is that each uniform payment consists of an interest component and a repayment of principal component, or an amortization component. And as we learned on the previous page, the interest portion is always, for that period, the beginning of period balance times the interest rate, and the amortization portion is always the total payment minus the interest portion. And then, as I just pointed out, at the end of the contract, the unpaid principal balance better be equal to zero. And of course, you're going to have some rounding error in that. But if you get something like $250,000 left to repay, clearly you've made a mistake. So this is a good way to check your work here. It's a good way to check your work. And also, something I didn't really stress or highlight on the last page is, as time increases, more of each payment goes to principal pay down. So let's look at how that works. So in year one, our interest payment amount is $3,000 of the $12,000, and our principal payment is just about $9,000. But in year two, you see we're paying less interest. Why? Because we're starting with a lower principal amount. So if we're paying less interest and the total that we pay is the same, more of what we pay is going to paying down principal. So here the principal repayment has gone up between years 1 and 2, and the interest payment has gone down. And again, the reason for that is because the beginning of period balance that we pay interest on has gone down. And then again, we see the same thing in year 3. Because we have a smaller balance to pay down, we pay less interest on that smaller balance. And because our uniform payment is constant, that allows more of that payment to go towards principal repayment. And again, you see here, I really want to stress this, at the end, after all the payments are made, the end of period principal balance is zero. Okay, here's a great page for those of you who are real estate types. Everybody else can ignore that.
All right, now let's look at a real world example. Potential purchase of the Apex apartments. So this is abstracted from a real project by some hedge fund friends of mine who specialize in purchasing, managing, and hopefully making a lot of money from off-student housing at various universities in the Middle East region of the country. So not quite as far out as Miami University. So this is a housing complex near Bucknell, and this is something they were thinking of purchasing, and we have some of the basic data here. There are 2-bedroom units, 900 square feet per unit, et cetera, et cetera, et cetera. Total square footage, 33,000. And the group doing this is called Core Asset Group, and let's see how this work. You can see here these numbers are pretty real. I have sort of prettified and simplified the mortgage, but most of the numbers are pretty much as they were in the real project. They ended up not buying this, but this was part of an analysis to see if they should buy this complex. Okay, so with that in our back pocket, so this off-campus housing apartment complex is offered to Core Asset Group after they've negotiated and all that for about 4.2 million. And so then they go out to lenders, mortgage lenders, right? And they get the first thing the lender says is, what's the loan to value going to be, the maximum loan to value I'll give this. So first of all, the mortgage lender agreed that this was a fair market price. Their appraised value was about the same as what CAG was going to pay for it. And the mortgage lender said, to have a safety factor, I'm not going to lend you this whole thing, but I'll lend you 80% of what I think the property is worth. So the mortgage lender is going to lend CAG 3.3 million, and CAG is going to have to cough up out of its own hedge fund cash 841,000. So the total, of course, adds up to the purchase price. The reason the lender does this is they want a safety factor. In case CAG just immediately flames out, the lender gets the keys to the apartment complex, and they've only invested 3.3 million, and if they think it's worth 4.2 million, even in that case, they can make money even if CAG defaults. So that's the idea there. Okay, so let's look at the details of the loan that they got. So the principal, as we discussed above, 80% of the purchase price, or about 3.4 million. This is a uniform payment, fixed rate loan, okay? Uniform payment, which again, we have sometimes called constant cash flow type of loan. Interest rate they got on this was 5%, which was actually pretty good at the time. And this was a 30-year term loan. So here's our cash flow diagram. This is clearly from the lender's perspective, right? Big negative cash flow for the lender initially, and then they're going to enjoy a series of uniform payments going out for 30 years, okay? And that CF0 is equal to the 3,366,891, okay? And then we can compute the uniform payment, okay, which is up here. How? Well, exactly using the same formulas we've always used. We just use our standard uniform payment formula here, and we know the interest rate. We know N is 30. We know PV tote is 3.3 million and change, and we plug all those numbers in and solve for C, and we get 219021. Okay. All right, so now let's see what the amortization table looks like for CAG for this loan. As usual, the important things are the loan principal beginning of period, what's the payment, the uniform payment, what's the interest portion, what's the principal portion, and then what's the principal remaining after the amortization has happened. So as you can see, just as was the case with Mr. Small Net Worth, everything looks pretty much exactly like it did before, right? In the sense that the EOP principal balance in period 0 is equal to BOP in period 1, and et cetera, et cetera. Also, you know here, as well as me, that it's a uniform pay mortgage, constant cash flow mortgage. So all of those uniform payments are going to be constant, okay? And you can see here the interest portion, you can figure this out for yourself, but 5% of 3,366,891 is equal to 168,345. We subtract 168,345 from 219,021, and we get the principal paid down in the first year is 50,677, right? So I'll just write that down here. 219,021 is equal to 168,345 plus 50,677, and the 168,345 is equal to 3,366,891 times 5%. Okay. So now I want to talk about some interesting features of this and all loans. So as I said before, as time goes on, and I've got a graph here of time on the x-axis and percent of annual payment on the y-axis, as time goes on, more and more and more of the amount that you're paying goes to pay down the principal, the amount borrowed, and less and less and less goes to the interest that you're paying. But the interesting thing about this is not linear, okay? The amount you're paying down the principal is growing exponentially, and the interest that you're paying is declining exponentially. So that has some sort of horrifically bad consequences for the borrower. So this is a table showing year, we have our 30-year loan here, versus the percent of the loan that is amortized. And you notice that we don't get to 50% amortized. In other words, we haven't paid off half of the amount owed until about year 24, okay? That's pretty horrific, all right? And that, of course, the lenders love, right? Because if something goes wrong, right? They still have the lion's share of the equity for a long time, and they're getting these big interest payments from you for a long time. Okay, so this has some implications here that basically if you have some free cash burning a hole in your pocket or your hedge fund's cash account, it's always smart to amortize early, and there are several reasons for that, but the key reason is you can pay the loan off sooner, and then you own the property free and clear sooner. All right, that's it for this chapter on amortization of uniform cash flow projects. So as always, if I don't catch up with you in the discussions or office hours, have a great rest of the week, and I'll see you in another video real soon.